What I'm going to do now is introduce you to all four forms of a parabola whose vertex is at the origin. We've already been introduced to the first type. The equation of the form y squared equals 4ax is going to be a parabola whose vertex is at the origin, whose focus is on the positive x-axis at a comma 0, and whose directrix is the vertical line x equals negative a. We note that the parabola opens to the right. If the parabola opens to the left, our equation is going to be of the form y squared equals negative 4ax. The vertex is still at the origin, but now the focus is on the negative x-axis at the point negative a comma 0. The directrix is the vertical line x equals a. Note again that the parabola opens to the right. Opens to the left. If the parabola opens up, the equation is of the form x squared equals 4ay, vertex at the origin, focus on the positive y-axis at 0 comma a. The directrix is the line y equals negative a. Finally, if the parabola opens downward, we have the equation of the form x squared equals negative 4ay. The vertex at the origin, focus on the negative y-axis at 0 comma negative a. Directrix the line y equals a. And again, the parabola opens down. So let's look at an example where we're asked to analyze the equation of a parabola. The equation is of the form x squared equals negative 12y. We should recognize this as an equation in the form x squared equals negative 4ay. This means that we have a parabola that is going to open downward. Here's the trick to solving this. When you have a y squared term, the parabola opens either left or right. X squared term, the parabola opens either up or down. If the x squared is going to be equal to a negative quantity, we open downward. If we have a positive quantity, we open upward. Comparing these equations, we can immediately see the value of a is going to equal 3. So we have a vertex is located at the origin. We have that the focus is going to be on the negative y-axis, so it's going to be at the point 0 comma negative 3. And our directrix is going to be the line y equals a, or y equals 3. While we're here, we might as well find the points that define the latus rectum. And the way we're going to find that is we're going to look or let the y value equal negative 3 in this equation and then find the corresponding x values. In other words, we're going to find the points that are directly to the left and directly to the right of the focus. So we get x squared equals negative 12 times negative 3, so that x squared equals 36, x equals plus or minus 6. So the points are 6 comma negative 3 and negative 6 comma negative 3. Remember, these points are going to help me to identify the width of the opening of the graph. So we go over to our graph and we plot these key points. I plot the origin, 0, 0. The focus is at 0 comma negative 3. Then I plot the latus rectum. I have it negative 6 comma negative 3. So negative 6 comma negative 3. And I also have one at 6 comma negative 3. So I plot another point at 6 negative 3. Now what I'm going to do is draw in my directrix, which is the line y equals 3. So there we go with y equals 3. And finally, we're going to trace in the graph of our parabola. It's a parabola that opens downward, and these latus rectum define the width of the opening. So there we have the graph of our parabola.